Hi everyone, have a nice day. This video is about my own summary for chapter 5 in NetAcad, which entitled as the Ethernet. So watch this. This chapter is about the Ethernet. So Ethernet is the most widely used LAN technology in the world today. It operates in the data link layer and physical layer. Ethernet is a family of networking technologies in the Institute of Electrical and Electronics Engineers, or the IEEE 802.2 and the 802.3 standards. An 802.2 is the layer 2, which is the data link layer, and also the LLC, or the logical link control layer, while the 802.3 standard is the MAC, or the media access control layer, in layer 2, and the layer 1, which is the physical layer. An Ethernet has two separate sublayers in layer 2, which is the LLC and the MAC. LLC stands for Logical Link Control, and the MAC stands for Media Access Control. A logical link control sublayer is the one who handles the communication between the upper layers and the lower layers. A media access control is the one that constitutes the lower sublayer of the data link layer, and it is implemented by hardware, typically in computer network interface card, or it is also known as the NIC, but the logical link control layer is implemented by software, and its implementation is independent of the hardware, and it can be considered as the driver software for the network interface card, or the NIC. A MAC sublayer has two responsibilities, which is the data encapsulation and the media access control. The data encapsulation has three primary functions, which are frame delimiting, addressing, and the error detection. The media access control is responsible for the placement of frames on the media and the removal of frames from the media. An Ethernet also have an evolution. Since the creation of Ethernet in 1973, its standards have evolved for specifying the faster and more flexible versions of the technology. The ability of Ethernet is to improve over time, which it may become popular. The early version of Ethernet is as low as of 10 Mbps, but the latest version of it now can operate up to 10 gigabits per second and more. From 1973 up to the year 2016, it became large, and a lot of messages or data can pass through it at the same time. Ethernet 2 is the Ethernet frame format used in the TCP or IP networks, and it has a frame fields including the preamble and the start frame delimiter, destination MAC address and the source MAC address, the ether type, data field, and the frame check sequence field. The minimum Ethernet frame size is 64 bits, and the maximum is 1518 bits. If the size of the transmitted frame is less than the minimum or greater than the maximum, the receiving device will drop the frame. Every network device is connected to the same shared media. Ethernet was once predominantly a half-duplex topology using a multi-access bus or the Ethernet hubs, so all nodes would receive every frame transmitted. The MAC address is often referred to as the burn-in address or the BIA because this address is burned into the ROM, or it stands for the read-only memory on the network interface card or the NIC. The address is encoded into the ROM chip permanently. And Ethernet NICs will also accept the frames if the destination MAC address is a broadcast or a multicast group of which the host is a member. Any device that can be the source or destination of an Ethernet frame must be assigned a MAC address that can be either a unicast, multicast, or the broadcast communication. A layer 2 Ethernet switch uses MAC addresses to make forwarding decisions. It is completely unaware of the protocol being carried in the data portion of the frame, such as an IPv4 packet or the Internet Protocol version 4. Every frame enters a switch is checked for new information to learn. And if the destination MAC address is a unicast address, the switch will look for a match between the MAC address of the frame and an entry in its MAC address table. But if the destination MAC address is a broadcast or a multicast, the frame is also plotted out of all ports except the incoming port. When a device has an IP address that is on a remote network, the Ethernet frame cannot be sent directly to the destination device, and it is sent to the MAC address of the default gateway or the router. Switches use a packet forwarding methods for switching data between ports, which is the store and forward switching and the cut-through switching. A store and forward switch is the one who receives the enter frame and computes the CRC or the cyclic redundancy check. CRC uses a mathematical formula based on the number of bits in the frame. It is used to determine whether the received frame has an error. And a cut-through switch is one who forwards the frame before it is entirely received. It has two variants, the fast-forward switching and the fragment-free switching. An Ethernet switch may use a buffering technique to store frames before forwarding them. There are two methods of memory buffering. The port-based frames are stored in queues that are linked to specific incoming and outgoing ports, and the shared memory, which deposits all frames into a common memory buffer that all the ports on the switch share. The most basic settings on a switch are the bandwidth and the duplex settings for each individual switch port. There are two types of duplex settings used for communications on the Ethernet network, which are the half duplex, where only one end of the connection can send at a time, and the full duplex, where both ends of the connection can send and receive simultaneously. Most Cisco switches and Ethernet NICs or network interface cards default to auto-negation for speed and duplex. The port that operates in full duplex is the gigabit Ethernet ports. There are two primary addresses assigned to a device on an Ethernet LAN, which are the physical address, which defined as the MAC address that is used for Ethernet network interface card, to the Ethernet network interface card communications on the same network, and another is the logical address, which define as the IP address that is used to send the packet from the original source to the final destination. The Ethernet frame layer 2 contains a destination MAC address and a source MAC address, while the layer 3 Ethernet frame contains a source IP address and a destination IP address. So to determine the destination MAC address, the device uses ARP. ARP stands for Address Resolution Protocol. It provides two basic functions, which is resolving IPv4 addresses to the MAC addresses and maintaining a table of mappings. ARP requests are broadcast. They are platted out all ports by the switch except the receiving port. Only the device that originally sent the ARP request will receive the Unicast ARP replies. As a broadcast frame, an ARP request is received and processed by every device on the local network. The use of an address resolution protocol can lead to a potential security risk known as the ARP spoofing or the ARP poisoning, whereas the attacker sends an ARP reply with its own MAC address and the receiver of the ARP reply will add the wrong MAC address to its ARP table and send these packets to the attackers. So this chapter shows how Ethernet evolved since its creation. So thank you for watching this video. I hope you understand and you learn from this video. So I'm Kisha Lyka Villanueva of IT 2105.